Awesome. So thank you for having me here today at the WNB.rb meetup. If you were at Brighton Ruby, which I know some of you were, this is my talk that I gave at Brighton Ruby a few weeks ago. I guess more than a month ago. Time is fake. It's fine. My name is Emily Samp. I am the engineering manager of the Ruby developer experience team at Shopify, as well as one of the founders of WNB.rb. So as a team, the Ruby developer experience team, our goal is to deliver an opinionated, state-of-the-art Ruby development experience to Shopify and to the Ruby community. To do that, we build and maintain developer tools for Ruby, such as the Ruby LSP, IRB, RDoc, the Ruby debugger, Tapioca, and Sorbet, which is going to be the main focus of this talk. So Sorbet is a Ruby type checker. And at its simplest, a type checker is a piece of software that verifies that the values in your program match the kind of values you expect, and then reports errors if they don't. So let's imagine that we write a method that is meant to greet a user by name. This method takes a string representing a username as an argument, and then concatenates that string with the phrase, hello user. So now let's imagine down the line, we forget what kind of argument this method takes, and we pass a number to it. This will raise an exception when we run the code because you cannot concatenate a number with a string in Ruby. Traditionally, Ruby is a dynamic language with no type checking, which means that many of us would catch this error in automated tests or our manual testing, or in the worst case, in production. However, there are third-party type checkers for Ruby, like Sorbet and Steep, that can help us speed up this loop. So if we were using Sorbet, we could add a type signature to this method, which is a piece of code that tells us the types of the method parameters and its return value. So because of this method signature, Sorbet could type check this code, and then it could tell us before we even run it that there is an error. So now, if you've been involved in the Ruby community for a while, you'll know that type checking is kind of a spicy topic. And I'm going to show you what I mean by that. On the one hand, type checking Ruby can have huge benefits. At Shopify, we adopted Sorbet about 6 years ago, and we've been surveying our developers ever since to see how they feel about Sorbet. In 2024, more than 70% of surveyed developers said that Sorbet helps them ship faster with fewer bugs. More than 80% said that Sorbet signatures give them confidence when they change code. And 85% said that Sorbet caught an error in their code. It is undeniable that Sorbet has had a large positive impact on how we write Ruby at Shopify. However, it's no secret that major voices in the Ruby community have been pretty outspoken about their dislike of types in Ruby. So this is a real slide from Matz's Ruby Kaigi keynote this year. He has been speaking out against types in Ruby for basically as long as Ruby has existed. So if types are so helpful at Shopify, why do Matz and other people in the Ruby community feel this way? They have valid reasons. Type checking in Ruby right now has some drawbacks. Type signatures can make code clunky. Sometimes we end up writing non-idiomatic Ruby code just to appease the type checker. And Ruby's reliance on metaprogramming adds additional type checking challenges, which we'll discuss later in this talk. Basically, Ruby's flexibility creates a sense of joy. Its syntax is expressive and fun. Its capacity for metaprogramming makes frameworks like Rails possible. And type checking runs the risk of ruining all of that. So where does that leave us? Is the Ruby community forever destined to be separated into two camps, one pro-typing, one anti-typing, never to agree on anything ever again? I don't think so. I think that whether or not we personally want types in our application code, we can all be excited about advancements in Ruby type checking. And that's because of static analysis. Static analysis refers to a variety of techniques for examining code without actually running it. So type checking is a form of static analysis. You examine the code without running it in order to determine the types of the objects in that code. Every developer tool we use, from RDoc to language servers to Rubocop and other linters, uses static analysis to learn about the code. The issue is that Ruby developer tooling needs better static analysis than it has, and I think type checking is going to help us get there. Advancements in Ruby type checking are currently driving the development of type-aware static analysis tools that will enable Ruby developer tooling to match the intelligence, accuracy, and responsiveness that developers have come to expect in other modern languages. During this talk, I'm going to explain where Ruby tooling is today compared to other languages and why it could benefit from better static analysis. Then I'll talk about how we got here, the history of type checking in Ruby and other languages, and how that history relates to advancements in developer tooling. And finally, I'll show you where we're headed, because even if you personally never add a single type annotation to your Ruby code, the future of Ruby tooling that's being built on these foundations is something you too should be excited about. So to understand what improved static analysis could do for Ruby developer tooling, we first have to understand the current state of the ecosystem. Ruby has an ecosystem of tools that do a limited amount of static analysis. We have Rubocop for linting, RDoc for documentation generation, Ruby LSP, which is a language server for VS Code and other development environments. These tools are valuable, but they struggle with some fundamental limitations, and so I'll show you some examples. So let's imagine we write some code that creates a hash mapping book titles to their ratings. Then we iterate through the keys in the hash and print out the title of each book. If we use Rubocop, this will create a rule violation, and I'm sure everyone has experienced this at some point. It'll raise a style hash each method violation, and say we should use the each key method instead of calling keys.each. So in context, this suggestion makes a ton of sense. It would be better to call one method instead of two. It's more idiomatic Ruby, etc. However, let's consider the following example instead. So what if instead we make a class representing a door, and we add a method to that class that returns a list of the door's keys? Then if we iterate through the keys to print some information about them, Rubocop is going to suggest changing the call to .keys.each to each key. However, if we did it this time, the program would raise an exception because the door class does not have an each key instance method. So why does Rubocop make a suggestion that would break our program? And the answer has to do with how Rubocop looks at our code under the hood. So under the hood, Rubocop converts code into something called an abstract syntax tree. This is a way for computers to represent code so that they can go through it and discover information about its structure. So these are the syntax trees for our two examples. Rubocop is going to look for the chained calls to the keys and each methods, and is going to use that information to declare a violation of its rule. This is static analysis, but it is not type aware. Rubocop has no way of knowing what kind of object these methods are being called on, and so it's kind of doing its work on a best guess basis. There are similar issues in other tools. So this is a screenshot from the Ruby language server, which is built and maintained by my team at Shopify. This is the state-of-the-art Ruby language server. I want to emphasize that up front. The goal of the language server is to provide helpful information like method autocomplete while you're coding. However, when we are not using something like Sorbet, autocomplete can only happen on a best guess basis, just like Rubocop in our previous example. So if we go back to our door example, we define a class called door, and then we create a variable called door and assign it to a new instance of the door class. The Ruby LSP does something kind of smart here. it assumes the door variable is an instance of the door object because they share the same name, and it gives us relevant method autocomplete suggestions. However, if we name this variable anything else, like Baker Street 221B, the LSP can no longer guess what it is. And once again, this is due to limitations in the underlying static analysis that it's using. However, if we look at something like a Python language server, it doesn't have this problem. It can, no matter what we name this variable, it can very easily determine what kind of object it is and give us relevant autocompletes. So it's not that Ruby LSP is bad software. Once again, it is state of the art for our language. It's that it simply cannot do any better because Ruby lacks high quality static analysis tools. And because of those limits, Ruby developer tools just cannot be as helpful as we would like them to be. So how did we get here? There are other programming languages, such as Python and JavaScript, that are just as old as Ruby and just as dynamic, and yet do not lack intelligent developer tooling. So how did they arrive at where they are today? We're going to examine the history of these programming languages next to Ruby to see how they compare. So Python, Ruby, and JavaScript were all released within 7 years of each other in the late 80s and early 90s. In the early 2010s, these languages started to be adopted at scale, and it became very obvious that they were facing some limitations. So this led to the earliest Python and JavaScript type checkers, which were MyPy and TypeScript, both released in 2012. The later 2010s saw further investment in Python type checking, but with the development of type checkers that are still in use today, in addition to further development in TypeScript, as I'm sure many people know from their own personal use. So if we compare this to the history of type checking in Ruby, the first comprehensive type checker for Ruby was Sorbet, which was developed at Stripe and released in 2019. Ruby 3.0 also included some type checking features. While Mats has been historically opposed to type checking, he is supportive of the RBS type checking syntax, which basically allows you to write type signatures in a different file so they don't clutter up your Ruby code. So what we can learn from this timeline is that investment in Ruby type checkers started almost a decade after Python and JavaScript. This led to disparities between the quality of static analysis tools available in Python and JavaScript versus in Ruby. And we can see that because every Python and JavaScript type checker provides static analysis for the language tooling that developers use every day in those languages. So type checkers power the Python and JavaScript language servers. That's why those language servers give you such good experiences. Python has a type-aware security issue detector that is built on top of a type checker. And there are type-aware linting plugins for most popular Python linters. So we would avoid that kind of Rubocop suggesting changes that would break our code situation. By contrast, there is almost no Ruby developer tooling that leverages type-aware static analysis. Why is that? Python and JavaScript have historically enjoyed greater popularity. This is a very sad graph for us, sorry. And that's probably because of their popularity being used in data and the web. However, that doesn't fully answer the question because there are companies like Shopify, Gusto, GitHub, and other large successful companies that do use Ruby. Another piece of the story is that Ruby is, of these three languages, the most dynamic and thus the hardest to statically analyze. So if we go back to our metaprogramming example from earlier in this talk, when we use Rails, we often will use methods like belongs to. And under the hood, belongs to is creating methods for us at runtime, meaning the methods that belongs to creates don't exist statically. So static analysis tools cannot see them before you run the code. Obviously, this is a huge problem because that prevents static analysis tooling from having a complete picture of what our code is doing, and so that really limits them. Another issue is Ruby's historical lack of shared tooling. So if anyone came to my talk at this meetup in October, you'll know that until a few years ago, there wasn't just one Ruby parser that you could take and use in any project. Instead, there were like at least 7. And each one was used in different developer tools, and each one had its own bugs and its own quirks. And so it's hard to develop more advanced tooling if you don't have a strong shared foundation that many people in the community are investing in. Given all these challenges, do you think it will ever be possible for us to achieve the kind of experience that developers in other languages have come to expect? I think the answer is yes. And that's because we're seeing some of these developments at Shopify right now. So the Sorbet LSP is a language server, like the Ruby LSP, that uses Sorbet type checking. It's developed by Stripe, and we use it every day at Shopify. So if we revisit our previous door example, unlike the Ruby LSP, the Sorbet LSP can very easily determine the type of the Baker Street 221B object, regardless of what it's named. In addition to more accurate method suggestions, it has accurate go to definition. It can find all implementations of abstract classes. It can find all references to a class or variable. It can easily rename symbols without missing some because they're used in slightly weird ways, etc. So it adds a lot of value to our development environment. We've also been developing CodeDB, which is a static analysis platform for Shopify repositories. It uses Sorbet under the hood to examine a code base and give us enough information to either analyze that code base or perform operations. So, for example, we can see how many files in a code base have Sorbet types, which is useful as we're tracking the adoption of Sorbet across Shopify. It can also find unused code and open GitHub PRs to remove it. And so to this day, CodeDB has facilitated the removal of tens of thousands of lines of code with very little human intervention. As a final example, many of us are familiar with IRB, which is the Ruby command line interface. So before Ruby 3.3, IRB autocomplete relied on a combination of regexes and runtime reflection. So it was cobbling together all sorts of information to try to provide you a good autocomplete experience. But this had its limitations. For example, you could call the keys method on a hash and IRB would know that method was available. But then after that, autocomplete doesn't give you anything else. It doesn't know what the result is of calling .keys on a hash. However, in Ruby 3.3, the Ruby maintainers made it possible to use Prism and RBS to power autocomplete. So now you get autocomplete when you chain methods, and it's more reliable and more robust. And this is the default in Ruby 3.4. So if your Ruby is up to date, then you are actively benefiting from this every single time you call IRB in your console. These examples are just the best we can do for now, but let's imagine what we might be able to accomplish in the future. So in the future, we could have an even better LSP experience. We could have it show you the inheritance hierarchies of your objects without you having to go look it up and trace every single call to include and prepend. We could have better inference in Sorbet with fewer method signatures, so it's not quite so clunky. We could have type-aware Rubocop cops. No longer will Rubocop suggest things that break your code. We could have LLMs leverage information from type-aware LSPs in order to better understand and better produce Ruby code. And the only way to reach this future is to invest more in type-checking Ruby. And by doing that, develop the static analysis tooling that will make all these dreams a reality. So I imagine that some people listening to this talk will have concerns about type checking still. So I wanted to take time to address them. First, many people don't want to use type signatures in their projects, nor should they have to. Gradual type checking, which is the approach that Sorbet takes, means that you get to choose how much typing to add to your code. That means you can type parts of your code while totally ignoring others. So let's look at an example that I saw at Shopify somewhat recently. Imagine that you have a boilerplate method that retries a block of code whenever you encounter a network error. You might use this method all throughout your application. And every time you see it, you might spend some time wondering how to use it or what it returns. So what if we just added a type signature to this method? This type signature is very ugly and hard to read. And that's something that we'll talk about in a second. But basically, it just says, whatever block you pass into this method, whatever that block returns, the method will have the exact same return value. So as long as you understand the block of code you passed into this method and you know what that block of code returns, you understand what the method returns as well. And that can provide you a lot of clarity as you use this throughout your code, even if you don't really type that much of the rest of your code. We could also imagine a use case where you rely on types coming from the gems that you use. So even if the rest of your project has no types, you can use types to kind of document a gems API and make sure that you're using it correctly. This would provide extra validation in the interface between our components. This is not possible without using Sorbet yet, but if you use Sorbet, there's a gem called Tapioca that will help you accomplish this and provide types for all the gems that you use. So another concern is that typing goes against the fundamental philosophy of Ruby. And, honestly, this is kind of true. Matt's designed Ruby to be dynamic, to be flexible, and typing kind of limits that. However, it doesn't have to be the case forever. So Matt has expressed interest in dynamic type inference for Ruby. This basically means one day he hopes that you could just write regular Ruby and the Ruby VM will be able to tell what the type is of every object without you having to provide any extra information. This is a very cool vision for the future. However, building an advanced tool like that requires us to invest in earlier, less sophisticated versions of the same tools. So if you've written any TypeScript in the past 10-ish years, 10 years ago, you had to use a lot of type annotations in order to make TypeScript useful to you. However, now you actually have to use a lot fewer because the type inference has gotten so much more advanced over the years. Ruby can follow a similar path. Our current clunky tools are just stepping stones on the way to more elegant solutions. But we can't get to invisible automatic typing without building explicit typing tools first. Speaking of clunky tools, many people don't like how clunky it is to type check Ruby right now. And I agree with that. But there are paths forward. So on my team at Shopify, we're currently working to change the way that you write sorbet signatures from the traditional syntax to RBS, which we mentioned earlier. Let's revisit the example that I gave before. So in this retry method, the signature in traditional sorbet syntax is long, it's hard to read, it takes up a bunch of space. However, with RBS syntax, the method signature is a comment with much, much simpler syntax. It is really easy to read and easy to write as well. If you scan this QR code, it'll link to a blog post from my coworker, Alex, and you can learn how to use this in your projects. So while there are many valid concerns about type checking in Ruby, they are rooted in the current state of type checking and static analysis. Instead of thinking in terms of how things are, I encourage you to imagine the future of Ruby tooling and see current tools as just stops along the road to a better destination. On the RubyDX team at Shopify, we are actively working on building this future into existence. So as I previously mentioned, we just wrapped up introducing RBS syntax for Sorbet. So this is making type annotations much easier to write and read, and that you can use today. We're deprecating Sorbet's custom parser and integrating Prism instead, as I talked about in my talk in October. And so we're making Sorbet easier to maintain for the long term and giving ourselves more room to contribute like meaningful features to it. And right now, we're working on creating a Ruby code indexer. This is going to be like the shared foundation for all of the static analysis tooling of the future. It will examine your code and be able to tell other tools what kinds of classes, methods, constants are available. So tools like Ruby LST, Tapioca, Spoom, and CodeDB could leverage that information and provide more accurate and performant features on top of it. And that's just the beginning. Through these projects, we are currently laying the groundwork for the next generation of Ruby developer tooling. This is the generation of tooling that will eventually deliver on Matt's vision of fully dynamic type inference in Ruby. This is the generation that will give us tooling just as fast, accurate, and intelligent as that of other languages. And it is the current advancements in Ruby type checking that are driving the development of static analysis tools that are going to get us there. If you're excited about the stuff I've talked about today, you can check out these resources to see how to get started yourself. You can explore Sorbet, adding Sorbet to your projects, and even using the Ruby LSP in VS Code to understand what the current state of Ruby static analysis really looks like. Thank you for having me. I hope you enjoyed this mildly spicy talk. I'm happy to answer any questions after or in Discord anytime. So please let me know if you ever want to talk about anything. And more importantly, I hope you are feeling excited about the future of Ruby developer tooling. I know I am. Thank you.